All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to continue learning about ESP32 and Rust development for the ESP32. Hopefully, we're going to make more progress today. I think I am probably going to be able to go for an hour and a half today. Honestly, I could have started the stream much earlier, but my procrastination habit slash issue, I don't know what to call it. Um, yeah, it is what it is. We could have gotten an extra hour of stream, but I got busy doing something else. Okay, so, um, oh, yeah, I was going to talk about something before we get into the main meat of today's stream. Um, okay, so in the past, I had heard about I was in the past. I looked for various different terminal emulators when I was trying to um, see like if I really need a different terminal. At the time, I didn't realize that yeah, the experience with um, one of these separate, I don't even know what to call them, aside from like third party emulators. That sounds kind of like weird to say third party. It makes it sound closed source for some reason. But basically, any other emulator other than what comes bundled with the OS. Um, Initially, when I'd started looking for other terminals, I didn't fully even think that I would need a separate terminal. I decided to give the Kitty terminal a try when I saw the various features that it had, many of which I didn't even know that I was going to be needing because I had just started my, let's call it terminal journey at the time. Um, and so I didn't realize the full power of these various terminals. And over time, I came to appreciate the various things that these other terminals do. Um, and I'm glad that I explored other terminals. So the first quote unquote other terminal that I explored was the Kitty terminal. Prior to that, I was using um, the, the terminal emulator that comes out of the box with Ubuntu, and the one that comes out of the box with Ubuntu Studio. One of them is, I think it's called the GNOME or Genome Shell. I forgot what exactly the thing is called, but it's something along those lines. On the Ubuntu side, that's what the default uh, terminal is called. And on the Ubuntu Studio side, I believe it was console. I can't remember, but yeah, I think it might have been console. So anyways, once I got into a terminal-based workflow, I decided to explore other terminal emulators, and of the few that I had explored, Kitty really stood out. Granted, I hadn't taken the time to go and explore, every single terminal emulator. However, um, what was I saying? Yeah, I hadn't taken the time to go and explore every single terminal emulator. Um, and so when I came across Kitty, I liked the features and I gave it a try, and I just stuck with it because Kitty is amazing. It's an amazing terminal. I'd heard about Wes term, which is what we are looking at here in the bottom left of the screen. That is, hold on, this terminal. I'd heard of this terminal, but I hadn't really looked into it. And I kind of wish that I would have looked into it, but also at the same time, I'm kind of glad that I didn't because that got me to explore the Kitty terminal. And now I'm exploring WesTerm. Yesterday, I looked into WesTerm and I found out that apparently this terminal is written in Rust, which is crazy to me. And that got me really interested in checking it out because I'm always looking for various tools that are made in Rust. I'm always interested in checking out various tools made in Rust, or rather, adding Rust-based tools to my let's say toolbox. And so I checked out WesTerm, and it turns out that WesTerm has a bunch of very useful features, very useful, as in I would find them very useful. Another reason I'm kind of glad that I took my time with eventually discovering WesTerm is that over time I have learned and developed a workflow, a terminal-based workflow. Like for example, what we've got going on here, for example, um, right now, what you're seeing in the top right and the bottom left of the screen, aside from the webcam, of course, what you're seeing in the top right and the bottom left of, sorry, did I say bottom left? Top right and bottom right of the screen are two separate tmux windows. So these are two separate tmux sessions that are running. Tmux is a terminal multiplexer, and basically what this lets you do is okay, I'm not going to go into the like general definition of a terminal multiplexer because there might be a couple of details here and there that might be a little different from what tmux is doing, but I'm going to tell you what tmux does. In tmux, you are able to create what are called tmux sessions. These tmux sessions can hold multiple tmux windows. Each tmux window can be split into multiple panes, and each of those panes can have a shell running inside it. So if you look at the bottom right now, and I start doing this, I'm switching between tmux windows, and within every tmux window, there is at least one tmux pane within which there's a shell running. So in this case, we have one shell running here. And most of my tmux windows are just single pane windows because I'm working with multiple screens, but I don't have a massive screen, or even like a big screen for that matter. I don't have any big screens, so split pane kind of thing, it doesn't really benefit me. There are very few situations where split pane benefits me. One of those situations is the streaming situation right now, because what you guys are seeing, I have this set up on a different machine. Like what you are seeing, the matrix rain taking up the entire left side, and the tmux window in the bottom right, and the tmux window in the top left, sorry, in the top right. All three of these windows are part of kitty, one kitty, I guess it's called a tab window, because the kitty terminal also lets you create like split kind of thing. But yeah, this is one example of like one of the few situations where I use the split pane thing. Usually, because because I have multiple screens. Usually, what I'm doing is just dividing things up into separate windows and separate sessions and stuff. Okay, so tmux allows you to host um, tmux sessions on a tmux server. By default, like when you start up the first tmux session on that machine, a server will get started up, and this session is being hosted on that server. Within this tmux session, which you can name, by the way, I have this one named, for example. So if you see here, I've named this one other laptop. So I have to type tmux attach, uh, and then t, and give it the um, what do you call it? Give it the name of the session. You can also list out your tmux sessions. So I have multiple sessions here. I can attach to whichever one I want. And the great thing is this works over SSH. So I'm currently actually doing this over SSH. I'm SSH'd into. I just realized that you guys can't see this. Hold on. I need to demonstrate the ability to detach on the other machine. My bad. Okay, so let's retry that. So I'm going to detach to show you guys uh, the session being detached from. I can't show you guys me doing it over SSH because I'm not capturing that window, but you're just gonna have to take my word for it that usually what I do is I SSH into this system, and because when you SSH, you get a shell. Then once I have the shell, I do basically this: tmux attach t, and then other laptop, which is the tmux session name. I can also list out the sessions, like you can see here, and yeah, I can then attach to whichever session I want. Okay, so turns out WesTerm has its own native multiplexing support, so you wouldn't even need to use tmux. WesTerm has native multiplexing support. It also has native SSH multiplexing support. So, and this is something I'm excited to test out because usually what happens here is I do the multiplexing, right? But the important thing is I need to be able to SSH into the machine in order to take advantage of the multiplexing. Because like I can set up the thing, but the whole idea is that I should be able to attach to that session from another machine across the network, because that makes it a lot easier given the way that my entire workstation is set up. So one of my more powerful machines that has more RAM, so it's more powerful only in that aspect, by the way. It just has more RAM. On that machine, I set up a tmux server with a bunch of sessions running, and then all the remaining machines on my network, I just SSH into this machine from those machines, and then attach to whichever tmux session I want. Now, okay, tmux is great. Tmux is amazing. It has been around for, I'm guessing, more than a decade. I want to say decades because I'm pretty sure this is a very old tool, but I don't want to give out wrong information just in case it hasn't been around for that long. I'm pretty sure it's been around for very, very long. Like it is an old tool. Actually, we can Google this right now. How old is tmux? Tmux was initially released in November 2007. As of March 2026, it is 18 years old. So this program is close to 2 decades old. That's crazy. Okay, so why was I talking about the age of tmux? I think I was just saying that, yeah, tmux is great. It's a very mature program. It's been battle tested in various ways. It is still being very widely used in even like companies and stuff. It's it is very widely being used. It's not the only program of its kind. There are many different types of terminal multiplexers, but tmux is definitely used quite a bit. That being said, it doesn't come without its quirks. You will run into small issues here and there. Sometimes there might be something color related. Sometimes there might be something, um, let's say, image or graphics protocol related. Sometimes there might be something clipboard related, so something related to copying, how the clipboard works. All of these things, like you will run into these issues if you're like spreading your workflow across multiple systems, which is kind of what I did. So because of that, I had to look into various settings which I would have to set in order to get things to work. Um, and I mean, for the most part, I've gotten things to work. There are still situations where it doesn't always work out that well. Um, that being said, now I'm interested in trying out WesTerm because WesTerm apparently has its own multiplexing support. You can do multiplexing within WesTerm itself. Another interesting thing is Western also has a built-in serial monitor in case you're doing embedded programming. So I found that really interesting because I've definitely been in, I mean, now we are doing this, right? We are doing electronic stuff. We are doing embedded programming. So we'll definitely be needing a serial monitor. It's not like I don't have any choices for serial monitors. At first I was planning on using the ESP flash tool because that has like a very basic serial monitor. But then if Western gives something decent in terms of serial monitoring, then that's great. Though there was a little caveat there, I remember. It was being mentioned that when the terminal is in serial monitor mode or in serial mode, some kind of mode they had mentioned, there are certain features that won't work. And this had me wondering if that only applies to that specific shell or if it applies to uh, the entire terminal window. Okay, there's still a lot for me to explore in WesTerm, but yeah, the reason I was interested, so I was mentioning about TMUX. I just remembered that I didn't finish explaining how TMUX works. So I explained this thing about sessions, right? So the great thing about these sessions is that you can open up any terminal on the local machine. You can open up any terminal window and then attach to the session. The session is running within the tmux server. You can just attach to it from the terminal. And this also works over SSH, which is why I'm able to SSH into the machine and then type tmux attach -t and whatever the name of the session is. So because these sessions don't necessarily need to have something always attached to them, they can remain alive even if nothing is attached to them. So if you have a terminal, if you have a terminal window that's currently attached to this tmux session, you can just detach from it and close the terminal window. But in the background, the tmux server is still running, and so the session is still alive. So the next time you can either open a terminal here or SSH into this machine and open a terminal. Well, I mean, you're going to get a terminal, you're going to get a shell. Once you SSH into this machine, you'll get a shell, and then you can you can attach to the tmux session over SSH. And that is basically how I've been doing the coding stuff for like months now. This is how I'm able to do it because when I'm typing stuff here, when I'm doing stuff in like in this window, moving back and forth here and there, I'm doing this over SSH. Okay, so now I've explained this thing about how, multiplexing works. You don't necessarily always need to have like a terminal window, a GUI window attached to it. The thing can run even if it's completely detached. Like if all terminal windows are detached from it, it can still run. The great thing with multiplexing is that multiple windows can be attached as well, or multiple terminals can be attached as well. So if you want to be able to see the session, if you want to be able to attach to the session from a local terminal on the machine, you can attach to it. And then when you SSH into this machine, you can also attach to that same session from that shell as well. Both the terminals can be attached to that one session simultaneously. And this makes it great for stuff like presentations or being able to do some kind of remote work or there's multiple use cases for this. But yeah, that's multiplexing, and the great thing is that you have SSH support in tmux, so you're able to use tmux multiplexing over SSH. And the amazing thing is that WesTerm apparently supports that as well. So WesTerm has multiplexing support, but aside from multiplexing support, it also has support for SSH. SSH as in with multiplexing. It has support for SSH based multiplexing. um, and it goes about it in a different way. Um, when you SSH, and this is I haven't tested this out yet, but according to Gemini, the way that it works in WesTerm is that you can give the command to attach to, they call them domains over here, in WesTerm. You can apparently attach to one of those domains or load up the domain or whatever the terminology is, and it opens up all of the tabs that you had open within that domain. It opens them up natively on your your WesTerm. So both of them are going to have to be WesTerm compatible, as in you're gonna have to have WesTerm installed on the remote machine and on this machine where you have the WesTerm domain set up. So on the remote machine, you can attach to this domain. Again, my terminology might be wrong here, but like you can attach to this domain or load up this domain or whatever. And apparently, all the tabs from this domain are just going to load up on that window. So everything just opens up there, and you are working in those tabs natively. And the and this is okay according to Gemini. Again, I haven't tested this out myself. Apparently, WesTerm is clever enough to be able to um, figure out when you are running a local tab and a remote tab. A remote tab is basically something that's running over SSH, and WesTerm is clever enough to allow you to mix these kinds of tabs together. So one tab can be a local tab, another can be a remote tab, and then maybe a couple more remote tabs, and then maybe a local tab or something like that. There's also apparently the concept of workspaces. Um, so I'm going to need to explore that part as well. But dude, all of this has got me incredibly interested in WesTerm. They have a list of the features here. Let me just load up that list real quick, and let's zoom in so it's a bit more legible. Okay, so multiplex terminal panes, tabs, windows on local and remote hosts with native mouse and scroll back. Ligatures, I'm not sure what this is about. Maybe this is something font related. I'm not sure. Then color emoji, font fallback, a bunch of like aesthetic stuff with true color and dynamic color schemes. I was, this was on my mind immediately. The moment I started looking at the terminal itself, this was on my mind because, dude, if I'm using a terminal, it needs to be Rose Pine Moon, like all the way. I've set up my Kitty terminal to be Rose Pine Moon. I've set up my Tmux theme to be Rose Pine Moon. I've set up NeoVim to also be Rose Pine Moon because that dude, that theme, that color scheme is just amazing. It is wow. Okay, so I looked into that, and yes, it is available. It is one of I think 700 other color schemes that are available. I'm mainly interested in Rose Pine, specifically Rose Pine Moon, because there are three variants. Okay, then they have hyperlinks and searchable scrollback. I have actually had situations where I needed something like this, a searchable scrollback. So this should be interesting to look into. I also wonder if they provide you with a way to kind of just read the scrollback buffer, load up or copy. That's the word I'm looking for. Select and copy stuff from the scrollback buffer. Oh, another thing that got me interested in WesTerm is that aside from the fact that the terminal itself is uh, implemented in Rust, it's written in Rust, scripting for the terminal, so any sort of customization, is all done in Lua. So it's got like very NeoVim kind of vibes there because customization in NeoVim is also done using Lua. And now I actually know what I'm doing when it comes to Lua, so I'm excited to jump into that as well. Um, okay, SGR style mouse reporting. I don't know what this means. I guess I'll find out what that is. Xterm style selection of text with mouse, paste selection with shift insert, bracketed paste, so and so. I don't know. I'll test that stuff out later on. Render, underline, and so on, so and so, so and so, so and so. Okay. Oh, I found this interesting. It says, okay, render, underline, double underline, italic or italic, bold, bold and strike through. Most other terminal emulators do not support as many render attributes. I didn't know that. Granted, I'm not often in situations where I have to do that, though, to be fair, that might already be happening without my knowledge, if that makes sense. Like, for example, um, when I use Gemini CLI, there are definitely times where something is underlined or something is bold, something is italic. I don't usually have double underline and strike through, but the others, yeah, I do. These are I have noticed situations where if the tool is actually terminal based, then the tool itself might implement that. I don't usually have the bold, italic, and stuff like when I'm typing commands, but when programs are running within the terminal, they might have that. And so having the support for that is great. Then configuration via a configuration file with hot reloading, multiple windows, split panes, split horizontally, vertically, move between panes, so and so. Okay. Then there's a concept of tabs as well. Let's play this video real quick. I don't, oh, back up, back up, back up, back up. Do I have audio muted? I do. Okay. So this is a video. Yeah. This is a video of the terminal. What is being demonstrated here? They were demonstrating tabs. Oh, yeah. Okay. Oh, another thing I was kind of I was kind of like concerned about was suddenly having to start looking at the top for the tabs because thanks to Kitty, I'm used to seeing the tabs at the bottom. Well, thanks to Kitty and Tmux, I'm used to seeing the tabs at the bottom. In my Kitty terminal, the tabs are always at the bottom. I don't know if you can actually put it at the top. I'm sure there might be like they might have added that option, but then I decided to just have the tabs at the bottom because it just for some reason it felt better having the tabs at the bottom and all of the other information on top. Okay, what else? Okay, we can pause this. Then SSH client with native tabs. This is where I found out that yeah, you can SSH into the machine and then load up those tabs natively, which is still like it's kind of wild to me. If that is the case, it changes things. It really changes things. Like big time. It changes things. So I could, for example, just have the terminal. Well, okay, I was thinking about like streaming wise, right? If I was trying to move my streaming setup to Linux to the Ubuntu side, then I could, maybe run these things locally. Speaking of running them locally, okay, well, not locally, remotely, but running natively, but still they're running remotely. So the program is running on the remote machine, but on, well, no, the program is running on the local machine, but on the remote machine, I guess that depends on like which point of view you're looking at it from. So yeah, on the remote machine, I'm basically using that remote machine as a terminal to operate on things in the local machine. It's crazy to me, dude, how far terminal tech has come. It is insane. And I'm kind of glad that I took Um, I'm kind of glad that I kind of took my time with it. I didn't immediately jump to West Term because I feel like there's so many things that I wouldn't have been able to appreciate about West Term if I hadn't, gone through all of that other stuff before. And of course, the fact that Kitty graphics support is there, so it supports the Kitty graphics protocol, and apparently a couple of other protocols as well. So I can see like if there is a need for the Kitty graphics protocol, then I can use it. Um, Maybe there might be certain tools that require the Kitty graphics protocol. Actually, one tool that does come to mind is Yahtzee. I want to Dude, yesterday when I tried to make this window disappear, things kind of broke. So what I'm gonna do is I'm just gonna switch to BRB real quick, do that Google search, and open up Yahtzee. Okay, Yahtzee, blazing fast terminal file manager written in Rust. Okay, awesome, great. While this is loading, we can do this, and we are good to go. Also, just for the sake of not having too much latency, we can do this and this. Okay, all right. So, Yahtzee did mention which all terminals it had support for, because Yahtzee has a file previewer utility where when you open up Yahtzee, like if I open up Yahtzee here, for example, and fortunately this works over SSH, so that's a great thing. Specifically, like the image protocol thing, it works over SSH because that's something you do have to worry about when it comes to wait, what's this code? Oh, okay, that's the build script. Yeah, something you do have to worry about while doing stuff over SSH and over a terminal multiplexer is that because there's multiple levels involved there, um, are all of the um, are all of the escape sequences going to be um, interpreted properly? Are they going to go into the right places where they're supposed to go, or is some level on either side going to see something that it's not meant to interpret, and it's going to assume it's garbage and then just strip it away? um, s- that's very much something that can happen. That has actually happened on certain other systems where I've tried to do this. For example, I think I'm trying to remember. I'm trying to remember exactly which. Oh, accidentally hit the key. I'm trying to remember exactly which. Um, yeah, I'm trying to remember the scenario, but there was one scenario where I was getting garbage, and it it was because the Kitty graphics protocol was not being interpreted correctly on the remote machine where I was trying to view something like, I don't remember if it was iCat or if it was Yahtzee or if it was something else, but the the data was being sent correctly from one side, but on the other side it wasn't being received correctly. I think part of the issue was that on the other side I was not using, so it might have been on the Windows, when I was like on this Windows machine, it might have been that I wasn't using the Kitty terminal. I was using the Windows terminal instead, which doesn't have Kitty graphics protocol support. That's why I was receiving garbage. By the way, I'm now seeing this remote file management thing. I don't know if I have ever actually looked deeper into what exactly this entails. Um, Also, this thing is mentioned. It's built on a client server architecture, no additional server process required, integrated with Lua. What am I looking at? I'm looking at Yahtzee. Dude, I feel like, yeah, I feel like there might be certain things that I haven't looked into in this file manager. Amazing file manager, by the way. Like, I could not recommend this enough. Um, oh, here it is. Inline image protocol. So there is support for WesTerm, which is amazing. That's great. Yeah, that's all I needed to look at. Um, and yeah, I'm gonna be trying out WesTerm. I'm not entirely sure. I have to test it out and slowly move my workflow over to WesTerm. And if everything works out well, we might not ever need to touch um, we might not ever need to touch tmux again, and we might actually move on from the kitty terminal as well. So we might not be doing tmux plus kitty anymore. We might just be doing WesTerm only. WesTerm, something that was kind of a negative point, but at the same time, once you take into account all of the various features that are at work, it's also not a negative thing. It makes sense. But initially it was kind of a gotcha kind of thing. Is that just running the terminal, not the terminal itself, but like whatever's running in the background, apparently it comes up to more than 300 MB. And so if you're running on a resource constrained system, maybe you don't want to do that. The Kitty terminal itself is pretty lightweight. That's not to say that anytime you open up a WesTerm instance, it's going to be additional 300 MB. I still have to explore that part, but that's not the case. Like, it's not like every single instance that you open of the terminal, it's gonna have that going on. In my case, I'm definitely using the multiplexing feature in it. Um, so it makes sense that this is going to be happening there because there's going to be like a background server that's holding this session even when I've like closed the terminal window and detached or whatever. But yeah, there's lots for me to explore. I'm thinking I'll explore this on my Ubuntu laptop because a whole that's where I don't have a whole lot going on in terms of like, working on stuff. With my other machines, I do have a bunch of things going on, and I can't really. I mean, I can kind of, but like, I would much rather do it on a machine where I don't have too much else going on. Okay, now I've been yapping for a good 40 minutes. Holy shit, that ran longer than I expected it to. Um, Okay, so we are going to jump back into this. And yesterday we were reading about BSP and HAL. I think we are done with HAL. Um, I think we were here. So HALs for the microcontrollers usually implement the embedded HAL traits, which are standard platform independent interfaces for peripherals like GPIO, SPI, I2C, and UART. This makes it easier to write drivers and libraries that work across different hardware as long as they use a compatible HAL. Throughout this book, we will use the ESP-HAL crate. The same HAL can be used with other ESP32 variants. To switch to a different ESP32 family, simply update the feature flag in the cargo.toml file. Note, the layers below the HAL are rarely used directly. In most cases, the pack is accessed through the HAL, not on its own. Unless you are working with a chip that does not have a HAL available, there's usually no need to interact with the lower layers directly. In this book, we will focus on the HAL layer. I like that they're explaining all of this stuff, explaining the various like levels. I feel like okay, there in the embedded Rust book, I think this was also explained, but I think I moved on from. Wait, now I'm curious about something. Hold on, because when I first started looking into Rust for ESP32, I was pointed towards the embedded Rust book. I looked into it for a little bit. I was still very new to Rust, so um, the all of that information didn't make a whole lot of sense to me. Um, However, I grasped whatever I could. I I believe that's also where I had seen the diagram about the HAL and the microcontroller and stuff like that. Or maybe it was the Rust on ESP book. I don't remember which one it is. What I do remember, okay, here it is. The embedded Rust book. We're gonna open both of these. That diagram, I remember that. I I do remember reading a bunch of information. Like I said, I wasn't able to grasp all of it as well. Um, but but that was enough to get me excited about it, and enough for me to be like, you know what? I'm gonna come back to this at some point later on and try and learn this. This might be it. I'm not sure. This doesn't focus on Yeah, this doesn't focus on ESP32 specifically. This doesn't focus on ESP32 specifically. Here it said that it's using the STM. By the way, after yesterday's stream, I looked into STM and Pico, and it seems like Pico is something I would be leaning more towards if I'm looking for something incredibly cheap. But at the same time, I had another realization that is, it kind of seems like it's a very small price difference, because I keep looking at the prices and I'm seeing like, oh, it's maybe 25% less or 15% less than what an ESP32 C3 Super Mini would cost, right? But then I'm like, why am I why am I putting the prices under such a microscopic lens and paying so much attention to the price as if it's like a massive price difference when it's basically a couple of dollars of difference. Because like the difference between them is not that big. The difference between an ESP32 and a CH32V003, that difference, yeah, I can probably pay attention to that, because that's anywhere between 50% to 60% less in terms of cost. But like um, a Raspberry Pi Pico, or not even a Pico, more specifically the chip, the microcontroller itself. Pico is the dev board. The microcontroller that's on it is called RP2040. That's the microcontroller that's on it. That is what I'm looking for. I'm looking for dev boards that have that specific MCU on them. So I don't necessarily even need to look for Pico. I can just look for that, and then any dev board that has that microcontroller, I can use it for, I can use it with tools that are meant for the RP 2040. What was I saying? Yeah, I realized when I kept on comparing prices, I realized that this this microscopic difference between the price is not gonna impact impact me all that much unless I'm trying to buy these things in bulk, which, to be fair, yes, I am trying to buy them in bulk because I want to have them as like for lack of a better term, throwaway chips. Just like anytime I have a quick project that I want to do, I want to be able to grab one of these and use it for that project. And so I want to be able to get them for as cheap as possible. But then, as great as RP 2040 is, and as cheap as it may be, it is not all that cheaper than ESP32. Yeah. Though, something that I haven't compared, I just realized this. I haven't fully compared the RAM and the processor in between both of these chips. And additionally, I have to also compare. Additionally, I also have to compare a third thing into like compare a third chip with these two chips, and that is the ESP32C3 Super Mini. So I have to see in terms of performance how do each of these compare. But I feel like the C3 Super Mini might just be what I'm looking for in terms of throwaway chips. I don't have a better term to use in place of throwaway chips, but like I'm not planning on throwing them away. They're not meant to be, single use chips. But I need chips that are cheap enough that I don't have to think twice before sticking them into some project that I want to hack, some appliance that I want to try and hack. I want to just be able to grab one of the chips and use it. And now that I'm thinking about it, I think I already have a good like six ESP32C3 Super Minis. I think so. I have like maybe six Super Minis, C3 Super Minis, and I have like three or four regular sized ESP32s. Some of them are Vroom, some of them are Vrover. Then I have one, maybe two, ESP Cam, ESP32s. I haven't touched those yet. I need to experiment with those as well. Though once we get more comfortable with programming ESP32 stuff, and once we get more comfortable with the embedded HAL API, then I'll probably be trying it out. Okay, I'm looking for where um, that diagram might have been because it was somewhere here, dude. It was definitely somewhere here. It was somewhere in this um, manual. Could it be the introduction section? No, that had the scope. Um, Hold on. Getting started. Okay, okay. Peripherals, static guarantees. So this, I guess this was giving like a more, I definitely didn't go through this book. Yes, I definitely didn't go through this book. And I believe it was because this was a more general purpose embedded Rust book, and I couldn't understand anything that I was reading at the time. And also because I soon also discovered the ESP32 Rust book, and I was like, okay, between a general purpose embedded programming book and an ESP32 embedded programming book, which one do I want to go with? I went with the ESP32 one because that's more focused on, ESP32, which is what I was using. I do wish I could find that image, but yeah, never mind. Okay, so this is the Rust ESP book. Could it have been here, maybe? So there's the embedded book. Oh, it mentions ancillary crates. This might have been where it was. Exploring the ecosystem of crates. Yes, this was it. Where's that image though? There was an image, not this image. There was an image. This is an ESP32, but there was an image. There was definitely an image that um, showed the various layers that are involved. I again, I can't remember where that was, but yeah. Um, okay, okay, going back to this or this. Yeah. Okay, peripheral access crate. Packs are the lowest level of abstraction. They are auto-generated crates that provide type-safe access to a microcontroller's peripherals. These crates are typically generated from the manufacturer's SVD, System View Description, file using tools like SVD to Rust. By the way, speaking of like generating stuff, yesterday I decided to look into this topic again because a while back I had okay this topic. Let me explain what quote unquote this topic is. Um, okay, yeah. So, uh, sorry, zoned out. What was I? What was I talking about? Oh yeah. So a while back when I was looking into ways to draw electronic circuits, I wanted to find like various different ways because I didn't want to always have to rely on like some GUI application. I wanted to see if there are other ways to go about it. And so I was looking for libraries, and this was like a while back. And ever since then, I don't think even Gemini was able to suggest this to me. I had to remember this myself. This was a one of a kind thing that I found. So this is a tool called Skiddle. Yeah, it's called Skiddle, as in Skidl. This tool allows you, this is a Python, it's not a tool, it's a Python library. This Python library allows you to programmatically describe a circuit, and then it gives you tools to export that programmatic representation into various different forms. So you can generate an SVG out of it, you can generate a dot graph out of it, you can generate some kind of file that KiCad can later view. And maybe there's a couple of other representations as well that you can generate. But it's great because you can describe your circuit in code form. And that is something that I've been looking for a while. Because like we can describe graphs in code form, right? Using the dot syntax. Why not circuits? Um, Thanks to this library, yes, you can also describe circuits. And I've been looking for something like this. Back when I had first looked into it, I don't think I fully grasped everything that it could do, but now I have a much better idea, and I actually want to try it out because if this allows me to programmatically describe my circuit and then export it as an image, holy shit, that's a gold mine for me. Um, Something even more amazing is that the I'm going to be able to export this circuit as a representation that I can later feed into an LLM and have it analyze the entire circuit for me to explain how stuff is working. That's something really powerful. That's something really important to me, at least, especially when I get into doing analog electronics. I'm going to have all sorts of questions. Like I remember yesterday, as I was having a conversation with Gemini about how to go about. Actually, yeah, I yesterday when I was doing more research on stuff that I'm going to need for like hardware wise, I realized that so there's a board called MB102. This is a board that's meant specifically to power your breadboard. So it's a board in which you can plug in a USB thing, like maybe your phone charger or your computer's USB port or something, you can plug it in to provide power. And on the board, they have I don't know about all the circuitry, but on the board they have voltage regulators that can step down the voltage and also maintain the voltage, stabilize the voltage to a fixed level. And the great thing is, it can stabilize it to a voltage of your choosing. So it can either be 3.3 volts, which is what the ESP32 uses very heavily, or it can be 5 volts, which is what Arduino uses. Um, and yeah, I realized that I'm going to need something like this because I was planning on so I bought these USB breakout boards, which are basically these chips that have a USB port and four wires. They're Type C, and it kind of shrinks. I mean, Type C has multiple data lines, but this it kind of shrinks those lines down to four lines, which is your plus minus, so your VCC and ground, and then plus minus of data. What I was planning on doing is splitting up, like using these breakout boards to power a breadboard and then use that to power various circuits. But then I was like, okay, what could be possible downsides of that? Um, and it turns out there are a few risks associated there. There's also no off switch there in case if I ever want to just shut off the power. I would have to unplug the thing, and that's the best way that I can actually switch it off. And I don't want to have to constantly unplug it. So this MB102 board is actually a good choice for me. Through this, I won't always need to have AA batteries. I can just use my phone charger to power my breadboard. Though something that does always actually, how would there might be a way to like prevent that. But what I was about to say is that something that does always kind of take precedence is the short circuit protection. In case if I accidentally short out the wires, then how bad is the damage going to be to the MB102? Fortunately, those boards are like dirt cheap, so I can order like three or four of them. They're super cheap. Um, and they're purpose built. They're built with that one specific purpose in mind. Something I didn't know is that they do have a current limitation. Apparently, it's around 700 milliamps. So if I'm using it for something like powering a servo motor module or a DC motor module, I probably don't want to plug the power in through there. I want to plug the power in from, an external source. And speaking of powering these modules and stuff, um, at one point we came to the topic of sharing ground, and that's where my old issue of not knowing too much about analog electronics kind of popped up again, because that's one of the main reasons why I've never been comfortable with sharing ground, because I always have these doubts and I have to clear up those doubts in order to be confident that, hey, this is what's happening. This is what could happen. This is what's not going to happen. And that way I know exactly what the situation is. I don't want to just head into something hoping that nothing bad happens. That's just not a good way to go about doing things. So I would like to get a better understanding. I forgot why I was talking about this because like I kind of branched out. Anyways, we're gonna continue reading this. Okay, packs give you a structured and safe way to interact directly with hardware registers. Then microarchitecture crate. This sits alongside the pack in the abstraction hierarchy. These crates are specific to the processor core architecture. Okay, I was right about that. I was taking a guess about this yesterday. I remember that. I was saying that maybe microarchitecture crate might be specific to each microarchitecture because each of these architectures have their differences. They have their different first of all their different designs, but also their different instruction sets. So compiling for one microarchitecture isn't the same as compiling for the other one. Otherwise, we wouldn't have these separate targets that we need to specify. They're both different architectures. Actually, they're all different architectures because some of these are ARM, and the two common ones that we see with the ESP32 are Extensa and RISC-V. At least with the newer ESP32s, it's all RISC-V. If you're still working with some of the older ones, which I am, then you would be using something like Extensa. Okay, they provide low-level access to core functionality and shared internal peripherals. For ESP32, this will be the Extensa LX and Extensa LX-RT crates. These handle operations like enabling and disabling interrupts and accessing internal timers. For ARM Cortex-based microcontrollers, such as those in STM32, NRF, or RP2040 families, the equivalent crates are Cortex M and Cortex M RT. These microarchitecture crates form the foundation that higher level HALs and BSPs build upon, ensuring compatibility and reuse across chips that share the same core. Okay, raw MMIO. MMIO is memory mapped IO. So raw MMIO means directly working with hardware registers by reading and writing to specific memory addresses. This approach mirrors traditional C-style register manipulation and require wait this approach mirrors traditional C-style register manipulation and requires the use of unsafe code blocks and Rust due to the potential risks involved. We will not touch this area. I haven't seen anyone using this approach. Okay, that would be something interesting to explore once we are more experienced with ESP32 stuff. All right, FAQ. Can I use other dev boards? Okay, all right, that's fine. Can I use other ESP32 family chips like ESP32C3? Yes, but the code may not work as is. ESP32 variants have different configurations. Some lack Bluetooth or Wi-Fi. Yeah, true, true. Okay. There could also be GPIO mapping differences. All right, fine. I cloned the project, but it gives errors. What should I do? Yeah, I don't think I'm going to be cloning the project. I have had these various types of errors in the past, so I think we're good on this front. We've especially something like this, we've absolutely come across this kind of an error, and in my case, the error was because I had to update the ES, I had to update the targets through ESP up. I still haven't like fully understood what exactly was the issue there because I did have an older version of the target installed. I don't know if updating because the problem seemed to pop up after I updated. I think so. After I updated ESP generate and and I think another ESP thing as well. I don't remember what, but yeah. Okay. Uh, this means the ESP32 cross compiler is not installed or not in your system path. If you're using fish, do so and so. If you're using bash, do so and so. Verify compiler path. Okay. Help troubleshooting. Okay. All right. That's fine. From STD to no STD. We have successfully flashed and run our first program. Yeah, that was there before. I have already done that. Like I've done my own version of that, so I didn't bother going through that section. Okay. However, we have not yet explored the code or the project structure in detail. In this section, we will create the same project from scratch instead of using the template. Okay, so I'd gone through this, and this is actually great because here they explain all the various working parts. Like if you look at this tree here, it mentions build rs, and then config.toml, cargo.toml, rust toolchain.toml, and then of course your code. Each of these files, they have like different things that mean something to this specific ESP32 Rust project. Each of these files impacts the project in a different way. And each of these files describes like words, what just happened. Each of these files describes various moving parts. Um, yeah, I forgot what I was going to say. But yeah, these files, they describe various very important moving parts within the project and how these moving parts affect the project. Okay, all right. Um, we have not yet explored the code or the project structure. Another thing, by the way, quick, I'm going to interrupt again. Um, Another thing that I liked is that it doesn't stop at just these files, these like, config files in the build.rs file. It also makes us write main.rs from scratch. I love the approach that's being taken here because you'll see this later on. As we go through these steps, the tutorial makes us write the various lines, and then it makes us try and compile the code, and then some error pops up. So the tutorial makes us make mistakes so that we realize, oh, this thing is necessary because of that, or this thing is necessary if we want that to happen, or you get what I'm saying. So it basically guides us through the why of everything. It doesn't just teach us the how. Give me a second here. Okay, I will explain. Wait, okay, all right. Give me a second here. Wait, are we good on frames? Let me just check that real quick. Sorry, I just need to confirm that we are good. Haven't dropped too many. Oh, damn. Okay, we haven't dropped any frames. That's amazing. That's great. So far, at least. I don't think that's happened in a while, but I guess there's still time, right? Give me a second. I'm just doing something. Okay, so back to this. Okay, I will explain each part of the code and configuration along the way. Are you ready for the challenge? Yes. Okay, create a fresh project. Let's do that here. Um, Let us also go into a different thing. So we're going to go back. We're going to create a new thing, ESP proj 05. This, okay. Cargo new STD to no STD. Okay, how are we going about this? Let's do, okay, cargo new wait, the project is in here. No, I'll just do cargo in it. I don't need that. That's okay. STD to no STD is just a name for the project. I can give whatever I want, so cargo in it is fine. All right, that's done. That creates our thing. Okay, now we open up the project. Um, this is our structure. Okay, our goal is to reach the following final project structure. Yes, okay, we're going to do that. Oh, that's interesting. I accidentally hit a key. I'm not sure what key I just hit. That, yeah, I don't know what key I just hit that made that pop up. But anyways, cross compilation. Rust allows you to build binaries. Give me a second. Yeah, Rust allows you to build binaries for operating systems other than the one you are currently using. This means you can write your code on one operating system and build binaries for a completely different one. True. For example, you can develop on Linux and build .exe files that run on Windows. You can even target bare metal controllers, bare metal microcontrollers like the ESP32 or STM32. In this section, we will explain how this works and what it means to deal with things like target triples. Okay. TLDR, we have to use extensor ESP32 non-elf. Yes, that is what we usually use in our thing, which is kind of interesting because I was confused when I didn't see this target being mentioned, but instead I saw a different target being mentioned. I forgot what the target name was. Hold on. The error might have popped up somewhere here. Hold on. It was somewhere in troubleshooting. FAQ. Yeah. When I saw this, I was confused. It says here extensor ESP32 ELF GCC. I was expecting, though, okay, this might be a specific linker. Now that I think about it, I should look into this because when I read this, the format that it's in made me think that maybe this is a target. Though when we talk about targets are, as far as I know, collections of files um, that are meant to allow you to compile the source for a specific target architecture. So perhaps the linker might also be a part of that if that's not already, available. Because, like, okay, in my case, I'm not doing RISC-V. RISC-V is already a part of Rust mainline, right? Extensor is not. Extensor requires um, a separate target, but also a separate Rust toolchain. So, like, when you use ESP up, you get all of that custom stuff that's required. I need to look into what is the difference between this extensor ESP32 ELF GCC and then what is our target, which is this. We have to use extensor ESP32 non-ELF as the target. Okay, as the target when building our binary for the ESP32. Cargo build target so and so. I've actually never done it in this way, so that should be interesting. Though, to be fair, I have most of the time been using um, just cargo build, which then invokes the build rs script, and then that does everything that needs to be done. Internally, maybe that's calling this because if we look at a verbose thing of if we look at a verbose output of cargo build or cargo run, then it's going to show, cargo build or cargo run for this specific type of project. It's going to show like a lot of flags being used and a bunch of like different binaries that are being invoked, I guess you can say. Okay, we can also configure the target in config.toml so that we don't need to type it every time. And yes, that is exactly what is done in when ESP generate creates the thing for you. Whereas our yeah, so you can see on the right. Oh, actually, you can't see it because I have the webcam there. No, no, you can see it. You can see it because I'm doing this on a different Tmux window. Yeah, yeah, you can see it. I forgot. Okay. So yeah, you can see on the right side it mentions um at the top of the file in the under the target section, it mentions the target. Actually, under the target section it mentions some information for ESP flash, but then there's a target flag being specified, a target field, sorry, being specified as well. Okay, all right. Back to this. Okay, building for your host system. Let's say we are on a Linux machine. When you run the usual build command, Rust compiles your code for your current host platform, which in this case is Linux. Rust compiles your code for your current host platform, which in this case is Linux. Okay. You can confirm what kind of binary it just produced using the file command. File so and so, so and so. You know what? We can test this out with one of the other things that we've looked at. Oh, I'm gonna have to use file here. Um, okay, let's open up a new thing and let's go back here. Rust proj oh 01. I believe I've run this, so there should be a target thing. Target debug Rust proj oh 01. So we're gonna. Oh, you know what? I think it ran that already. Yeah, yeah. Actually, it ran that already. It did. Okay, so this is invoking here. In order to get the information, Yahtzee is internally invoking the file thing, the file command. That's good to know. Hell yeah. Um, okay, this will give you an output like the following. This tells you it is a 64-bit ELF binary, dynamically linked, and built for Linux. Okay, all right. Okay, cross-compiling for Windows. Now, let's say you want to build a binary for Windows without leaving your Linux machine. That's where cross-compilation comes in. First, you need to tell Rust about the target platform. You only have to do this once. Rust up, target, add, so and so. Okay. This adds support for generating 64-bit Windows binaries using the GNU toolchain. Now build your project again, this time specifying the target. Okay, that's it. Rust now Rust will now create a windows.exe binary. Even though you're still on Linux, the output binary will be located at so and so. Do I have that target? I don't think I have that target. I don't want to install it right now, but that's actually something worth looking into because I've never thought about it in this way. To be fair, I've never actually had to do cross compilation other than, now the embedded programming. But other than that, when doing just uh, I guess desktop Rust application development, specifically with Rust, I've never had to actually do cross compilation. Um, so I never had to explore this. But now that we are doing embedded programming stuff, we kind of have to explore this. And I'm glad that we are also touching, or the tutorial is also touching on the Windows side of things. So cross compiling to Windows, because it would definitely work in that way for me. I would never actually be doing the development on Windows and then compiling for Windows. I would much rather do the development on Linux and then compile that binary for Windows. And this is great because like I could in this way also launch various Rust applications. Like I was planning on creating this sort of what do you call it? I was planning on creating this application, a terminal-based application, maybe TUI, but like definitely a terminal-based application for sorry, lost my train of thought for a second. Um, yeah, for controlling the OBS WebSocket server. Fortunately, the web server is already set up in OBS. They have their own communication protocol as well. And there are already a bunch of libraries that have been implemented to be able to communicate with an OBS WebSocket server. There's one such library in Rust, and it's good to go. You can just directly start using it. So what I was planning on doing was running that binary on the Linux side, so that I could, send commands easily. I still might actually do that, to be honest. I still might do that, but compile, being able to cross compile from Linux for Windows, definitely something I would like to know about. And it's this simple. Like all I had to do was add the target and then run the compilation. Granted, the tool chain must support that kind of compilation. Um, Fortunately, in this case, yeah, it does. But yeah, the tool chain must support that kind of compilation. It must support the architecture as well that you're compiling for. Otherwise, you end up in situations like, extensor. But yeah, other than that, it seems to be pretty frictionless. Okay, you can inspect the file type like this. Okay, all right, awesome, great. What is a target triple? So what's this x86 underscore 64 PC Windows GNU string all about? This is what we call a target triple, and it tells the compiler exactly what kind of output you want. It usually follows this format: architecture, vendor, OS, and ABI. But the pattern is not always consistent. Sometimes the ABI part won't be there. In other cases, even the vendor or both vendor and ABI might be absent. The structure can get messy and there are plenty of exceptions. If you want to if you want to dive deeper into all the quirks and edge cases, check out the article "What the Hell is a Target Triple?" linked in the references. Let's break down what this target triple actually means. So architecture x86 underscore 64. This just means 64-bit x86, which is the type of CPU most modern PCs use. It's also called AMD 64 or x64. Vendor PC, this is basically a placeholder. It's not very important in most cases. If it is for Mac OS, the vendor name will be Apple. OS, this tells Rust that we want to build something that runs on Windows. ABI GNU, this is the part that tells Rust to use the GNU toolchain to build the binary. All right. Compiling for microcontroller. Okay. It gets interesting here. Okay. But we are not going to do this right now. In fact, I'm not even going to do this off stream because I'm going to continue looking into Wes off stream. That being said, I think I'm going to end here. But do stick around. I'm going to be rating someone. Um, hold on. Give me a second. Uh, I don't. Oh, yeah, I do remember this person. Okay. Okay, let's look and look and look. Um, okay, let's see if this person's stream is um well accessible to us. And what's going on here? Fi cleans. Okay, let's open this up as well. Oh God, my fans are gonna go crazy. Well, I cannot do anything in this chat, so let's move on from there. All right, you know what? We are gonna go to this person's stream. I have no idea what they're doing. Actually, wait, let's keep searching. Okay, this person's also doing something. I'm not sure what they're studying, but I like what I'm seeing here. I have no idea what they're doing. I'm loving the entire like aesthetic. So I think we'll go here. Um, yeah, I think we'll go here. They've already been streaming for like for close to 5 hours, maybe. I don't know how long they're gonna be going, but yeah, we're just gonna go to this person's stream. Okay, so that's gonna be it for today's stream. Off stream, I'm gonna continue reading up on Wes term, and I'm actually gonna test it out because if I'm able to like figure out all the basics of this terminal and I'm able to like quickly port all of my stuff that I'm trying to do over to it, that's just a gold mine for me. That's amazing. I can very easily just transition from Tmux plus Kitty to just West term, and we are good to go. And yeah, I'm excited. I'm gonna play around with West term today. So that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.